Okay, still going to stick with trig. We're moving into a section where you're not going to really learn a whole lot new. It's story problems. So what makes that tricky is you have to come up with the triangle yourself from the story problem. And then once you've got that triangle all set, then it's just your regular SOHCAHTOA stuff. So speaking of SOHCAHTOA, I always like to put that at the top of the paper. Now the story problems, some new phrases for you are going to be angle of elevation and depression. So let's talk about those before we do our examples. So angles of elevation and depression. So the way these work is it's mostly referring to your line of sight. When you look straight ahead, so let's get some ground. This is the ground. Here's a person. Here's an eyeball. Okay. If they're looking straight ahead, parallel to the ground, you're not looking up, you're not looking down, so that's a 0-degree angle of elevation or depression. So it's your reference line, it's your starting point. You're always going to be drawing in a 0 line. Now if you have to look up to see something, a bird or a plane or something, so now your line of sight is looking up, the amount you go up from that 0 line, whatever angle measure that is, that's called your angle of elevation. Angle of elevation. So back to the 0 line, if there's something that you have to lower your eyes to see, big ugly spider coming at you, it's from the 0 line down. Always from the 0 line. This is the one where people make mistakes. They'll want to put the angle of depression down here, but it's from the 0 line down. This is your angle of depression. So let's let our first example be distinguishing between these two. So here's some level ground, here's a hill, here's the top of the hill, one person down here, one person up here, and something up in the sky here. Plane. Bad plane. So this person's 0 line, you always want to have 0 lines, would be straight ahead. This person's 0 line would be straight ahead. So these two people are going to look at each other. There's an angle created here. Call it angle 1. Here, we'll call it angle 2. And then this person is going to seesaw the sun. 3. So we want angle of elevation and angle of depression. So let's go for angle 1, because this person, if you look, is from the 0 line you have to go up. That's an angle of elevation. This angle 2, notice it's connecting the 0 line and down. So this is an angle of depression. And then angle 3 is connecting the 0 line and the line looking up, so this is an angle of elevation. So that's the 0 line and the above, that's elevation, 0 line and down. This one's 0 line and up. So always start at the 0 line and then go to your other one. 0 line to the other one. Hopefully you've got that. Okay, now we just have about 4 examples with story problems. And again, the tricky part is getting the picture. Once the picture's there, we'll do some SOHCAHTOA and it's pretty easy. So we've got, I'm not going to write the whole thing out, I'm just going to write the key information down. An air traffic controller spots a plane at an angle of elevation of 41 degrees. The plane is at an altitude of 4,000 feet. Question is, how far horizontally is the plane from the airport? Okay, so put all your key information. We've got the air traffic controller that's at the airport. So this will be the airport. Airport, AP. And then we've got our plane in the sky. So here's the ground level. So here's what we know. The plane is at an angle of elevation of 41 degrees. That means the air traffic controller being at the airport, his zero line is going to be even with the ground. Even though he's in a tall tower, we're going to consider that negligent here, because however tall that tower is isn't going to come into play. But from the zero line being the ground, again, you always need a zero line when you see angle of elevation or depression. So there's our zero. He looks up to see the plane. There's my line of sight, and that is 41 degrees. 41 degrees. So the plane has an altitude of 4,000 feet. Remember, altitude is just height. So that means if I drop a vertical here, I'm going to make a nice right angle. This is 4,000 feet. And then the question is, how far horizontally is the plane from the airport? So it's really looking for how far horizontally, not at an angle, but horizontally. So that's the equivalent to this bottom distance here. So they're really looking for how far horizontally until this plane is right over the top of the airport. But we'll just bring that down here. So now it's just a matter of labeling, standing here at the 41. This would be my opposite. This would be my adjacent, because the hypotenuse would be over there. So opposite and adjacent, if I look at the top of my paper, that's TOA. So I'm going to set up a tan. O and A are in the tan. So, simple setup, tan of 41. I have to put opposite on top of adjacent. Make some proportions, do cross products. X gets multiplied by the tan of 41. 1 times 4,000. Divide by the tan of 41. Let's see what I got here. Clear. 4,000 divided by the tan of 41. A little over 4,600 feet. Okay, so like I said, it's just story problems. You got to come up with your own picture. So the next one. Example 3. Says the Seattle Space Needle casts a shadow of 67 meters. The angle of elevation to the top of the Space Needle is 70 degrees. How tall is the Space Needle? Okay, so it's all about the picture. So, Seattle Space Needle, kind of shaped like this. And then here's our ground level. Here's the sunshine, creating this shadow on the ground here. There's the shadow on the ground. Okay, so I see this angle of elevation. Anytime we have that angle of elevation or depression, we need a zero line. So while there's not a person's eyeball here, what's doing the looking? Well, it's assumed that the tip of the shadow is doing the looking up to the top of the Space Needle. So the tip of the shadow's zero line would just be the ground, parallel to the ground. So then he looks up to see the top of the shadow, seeing the top of the Space Needle. That angle up is 70 degrees. Our right angle is going to be here on the ground. And we also, the shadow is 67. And then the question is, how tall? Once the picture's here, it should be pretty easy to figure out. So standing here, this is my adjacent, opposite, and the hypotenuse is not used. Again, it looks like a tangent. So tan 70, opposite is the x, always opposite over adjacent. Notice this time the x is in the top, so we're going to have our answer when we multiply 67 times by the tan of 70. 67 times tan 70, 184, about 184 meters tall. Okay, just one more for you. Number 4. Let's see, a forest ranger is standing on top of a 90-foot observation tower. So during fire season, there's somebody on top of the observation tower looking for fires to start up. He sees a fire at an angle of depression of 13 degrees. Find the horizontal distance to the fire. Okay, so get your picture going. So you've got the guy on top, here's the ground, here's our observation tower, got a nice railing around it, got your guy standing inside of it. Okay, so 90-foot tall observation tower, so we're going to put that at his eyeball level. So he's 90 feet up in the air. Here's our 90-degree angle. Angle of depression to the fire. Always put a zero line in first. Zero first. So his eyeball, zero line is straight ahead. If he drops his eyes 13 degrees from that zero line, he will see the fire. So the fire is down here. The 13 degrees is here. Okay, now the question is, how far horizontally is it? So we're looking for this horizontal distance. Well, if you were in class, I'd be asking for some volunteers here on, take a look at our triangle. The only angle we have in here is the 90. This 13 is outside of the triangle. So if I asked, I'm sure there'd be people that would come up with, you could find this top angle here inside of the triangle by going 90 minus 13, because this would be a 90-degree angle here, the vertical and the horizontal. So to get this one, you could go 90 minus 13, not because of that 90, but because there's a 90-degree angle here. Or, and that would leave us with, 77? Somebody else might come up with, well, if this is 13, remember the zero line is parallel with the ground, you can go alternate interior and bring that 13 down here. So you can find both of these angles. We only need one of them. I usually go with alternate interior, then I don't have to do any subtracting. But either way, now I can stand here at the 13, not at the top. Opposite. Adjacent. Oh, looks like another tan. I picked 3 tans today. Sorry about that. They won't always be tan, but the tan of 13 will equal opposite is 90 over adjacent. This time the x is back in the bottom, so it's going to be a division. At this point, you might be getting good at this and know what to do without showing the middle step, and that would be fine. This is what I need with an answer. If you want to show the middle, go ahead. 90 times 1, x times the tan of 13, and divide by the tan of 13. So we will find out that the fire is almost 400 feet away. Well, that's not very far. Oh, that's why it was 3 degrees. I'm like, that's really close. This was supposed to be 3 degrees, not 13. 3 degrees. Let's fix that, because I was going to say 400 feet away, that's like right on top of them. So that puts 87 in here, 3 down here. Fix this up, have this problem make a little more sense. So 90 divided by the tan of 3, there we go. 1,717 feet away. It's about a quarter of a mile. So that's better. Okay, so today you've got a story problem. Hopefully you do well.